I did not expect to be standing before this council today. That is not a rhetorical opening. I mean it with a precision the record should reflect. When I submitted the proposal for Habitat 7, I expected to close the study within 42 standard cycles, file a routine behavioral extinction report, and return the subject in acceptable condition to the interspecies repatriation queue. I expected a data set that confirmed what every prior closed habitat study in our archive had confirmed, that prolonged, enforced meaninglessness will eventually cause any cognizant species to stop, to go still, to cease all non-survival effort and enter the passive state our field calls terminal plateau. Every species we have studied reaches it. It is not a failure of the individual. It is a physiological and neurological truth. The brain, deprived of consequence, eventually conserves itself by abandoning the production of directed effort. I expected the human to reach it. I am standing here today because the human did not reach it. My name is Vo Sarin. I hold the rank of Senior Containment Researcher under the auspices of this council. I have conducted 11 closed habitat studies across 9 species over a career spanning 4 decades. I have never filed an anomalous outcome report. I have never requested an emergency council review. I am requesting one now, and I ask the council's patience as I walk through the archive in sequence, because what happened in Habitat 7 does not compress well into a summary. The shape of the data is the argument. You need to see it build. I will begin with the methodology, because the council should understand how carefully this study was designed, before I explain why the design was insufficient. Habitat 7 was constructed according to the Closed Behavioral Extinction Protocol, Revision 14, the most refined version of the methodology our division has ever produced. I personally oversaw the habitat's preparation over a period of 12 working cycles. I had 3 qualified engineers verify every structural component. I had our xenobiological compliance officer review the life support specifications against the human physiological baseline 4 separate times. I did not want any ambiguity about conditions. When this study produced a result, I wanted that result to be clean. The habitat itself measures 31 meters by 18 meters, contained on all 6 axes by high-density alloy paneling, with a compressive yield strength that exceeds anything a single biological subject of human mass could produce. I want to be precise about that number. The panels are rated to withstand 11,000 kilograms of distributed force across a 1 meter square area. The strongest load-bearing tests we have on file for an unassisted human in peak physical condition top out at approximately 450 kilograms, concentrated. The panels were not a concern. They were, if anything, over-engineered for the purpose, because the previous record holder in our extinction studies, a large-mass territorial species from the Outer Rim Survey, had breached a standard spec panel on cycle 73 of their study, and I did not want that complication. The interior was furnished to the minimum standard required by the Interspecies Study Compact. Sleeping surface, water reclamation point, food distribution node cycling on a 26-hour schedule, ambient lighting cycling between a simulated day state and a reduced illumination rest state. Temperature held at the subject's documented thermoregulation optimum, which for a human averages between 20 and 22 degrees on the standard index. Air composition matched to the subject's origin world atmospheric baseline within 3% tolerance. The subject was also provided a single emergency signal cord, standard compact requirement, for medical situations requiring intervention. Everything the subject required to remain alive and physically functional was provided. Everything else was withheld. No communication channels, no access to information, no external events, no varying stimuli beyond the lighting cycle and the food cycle, both of which operated on fixed, unalterable schedules. The walls were smooth. The floor was smooth. The ceiling carried only a single illumination array. The food port delivered identical nutritional packets at identical intervals. The water node delivered at pressure on demand. There was nothing to learn. There was nothing to do. There was nothing to change or improve or understand because we had already provided everything, and everything was permanent. This is the design that produces terminal plateau in every documented species. You remove consequence. You remove problem. You remove the gap between current state and desired state, and eventually the cognizant brain stops producing the drive to close that gap because there is no gap to close. The brain learns that effort produces nothing. It stops producing effort. The formal literature describes this as the organism entering a maintenance state. All resources redirected to basic physiological upkeep. All cognitively costly directed effort functions suspended or reduced. In species we have previously studied, maintenance state is indistinguishable from clinical depression in its surface presentation. The subject eats, drinks, breathes, sleeps, and does little else. But it is not pathological. It is adaptive. It is the brain responding correctly to an environment that does not reward directed effort. We are not harming the subject by reducing them to maintenance state. We are observing a fundamental truth about how cognizant brains work. I had every reason to believe the human would respond identically to every other subject we have studied. The human did not read my methodology. I want to start at the beginning of the session log, because the beginning is almost comforting in its familiarity. When we transferred the subject to Habitat 7 on the morning of intake day, the initial behavioral readings were entirely consistent with documented human species stress responses. Elevated cardiovascular rate, heightened cortisol analog production, rapid visual scanning of the enclosure perimeter. The subject moved from wall to wall in the first 2 hours, pressing hands to the alloy panels, searching for seams, testing corners, knocking on surfaces in systematic patterns. This is normal. Every species does something equivalent on intake day. The enclosure is new. The brain is problem-solving because the brain believes there is a problem to solve. What I noted in my intake observation log was that the subject's scanning behavior was unusually systematic. Most species circle the enclosure with a degree of randomness. Their exploration is driven by agitation, and agitation is not methodical. The human moved along each wall in sequence, covering each wall entirely before moving to the next, and applied pressure not randomly but in a grid pattern, working from top to bottom, left to right, covering the panel surface with a thoroughness that suggested they were not simply looking for a door. They were assessing the structure. By cycle 3, these exploration behaviors typically begin to moderate. By cycle 10, they are usually absent. The subject has, by that point, learned what the enclosure is: permanent, unchanging, not a puzzle with a solution. The problem-solving circuits begin to power down because they are receiving no reward. The brain is not cruel. It does not keep manufacturing costly neural effort for a problem that has no answer. It learns, it adapts, and the adaptation is stillness. Our subject reached cycle 3 with their exploration behaviors still running at intake day intensity. This was mildly notable but not yet outside the range we have documented in resilient species. Some subjects take longer to accept the enclosure. I logged it and moved on. By cycle 10, when I would have expected a significant reduction in directed activity, the subject had done something I had not predicted. They had mapped the room. Not metaphorically, I mean they had produced a physical map. Let me explain how. The food distribution node delivers nutritional packets wrapped in a thin insulating material, a film designed to retain temperature across the delivery window. The film is roughly 14 centimeters by 9 centimeters, and it is discarded by every other species we have studied after consumption. They eat. They discard the wrapper. It accumulates until our maintenance cycle clears it. The subject did not discard the wrappers. By cycle 10, the subject had accumulated 41 wrappers, smoothed them flat, layered the edges, and used the residue from the nutritional paste inside, a dark, adhesive substance that we use primarily as a binding agent in the paste composition, with no intended secondary utility, to join them into a single continuous sheet approximately 80 centimeters wide and 60 centimeters tall. On this sheet, using a fragment of the harder packet casing scored to a point against the wall seam, they had drawn a precise dimensional diagram of the habitat. I want to be exact about what this diagram contained. It included accurate measurements of all 6 walls, accurate to within a few centimeters, which is remarkable given that the subject had no measuring instrument and presumably derived all dimensions from their own body as a reference scale. It marked the food port, the water node, the illumination array, and the 4 ventilation micropoints in the upper corners, micropoints that are 3 centimeters in diameter and recessed behind a grill, rated to withstand 400 kilograms of direct compressive force, which made them practically irrelevant as potential egress. The subject had located all 4. They had marked each one. They had annotated the diagram with what I can only describe as notations, symbols I had to cross-reference with our xenolinguistics log to partially parse, indicating, apparently, estimates of the grill material and the depth of the recess channel behind each one. I reviewed this and I wrote in my session log, subject is engaging in displacement activity, purposeless simulation of problem solving to maintain arousal state. Estimated this behavior will extinguish within 15 cycles as the subject's cognitive processes register the futility of the task. I was wrong. I want the council to understand that clearly before we proceed. I was wrong, and I was wrong in a way that compounded over time, because I kept applying the same explanation, displacement, simulation, futile arousal maintenance, and the behavior kept not extinguishing. By cycle 20, the subject had revised the map 4 times. Each revision was more accurate. They had discovered, through patient and systematic pressure testing of each wall panel in sequence, that one panel in the northeast corner had a marginally different resonance when struck, a difference of approximately 2 millimeters in panel depth, which a sonic dampening test we ran later confirmed was the result of a minor manufacturing inconsistency in the alloy mix. The panel was not weaker. It would have taken industrial cutting equipment to breach it, but the subject found it. They marked it on the map. They went back to it every cycle. They sat in front of it and thought. I don't use the word thought casually. Our behavioral sensors, the subdermal monitoring we'd applied during intake, per standard compact protocol, tracked the subject's neural activity throughout the study. I had our biometrics specialist, Tar Rothais, review the data from the subject's sessions near that panel. What he described to me was difficult to translate into precise language, but I'll give you his summary as he gave it to me. The subject was running problem state cognitive engagement at a sustained level he associated with active planning tasks in observed human professionals. Not rumination, not anxiety cycling, planning. The brain was treating the panel as a problem with a solution. It was allocating resources to finding that solution. There was no solution, but the brain did not know that. Or, and this is the part I kept returning to, the brain knew it and kept working anyway. By cycle 30, the subject had begun what I will call a physical conditioning program, for lack of a better term. Every morning cycle, after the lighting state shifted to full illumination, and after the food cycle delivered, the subject engaged in an extended sequence of physical exercises. Not the restless, stress-driven movement of the early intake period. Structured movement. Repetitive. Progressive meaning they were adding to it, incrementally cycle by cycle, as if working toward some physical standard they had established for themselves. The sequence lasted approximately 90 minutes each cycle. It never varied in its basic structure, only in its demands. The same forms repeated with greater resistance or greater duration than the previous cycle. A protocol, self-designed, self-enforced. in a room where there was no physical demand placed on them. They were manufacturing a physical demand and training against it. I brought this to my colleague Reth Venaz, who holds the senior position in our xenobiology department, and I asked her to explain it. She told me that physical self-maintenance under conditions of enforced idleness is a documented human behavior, recorded in several field studies. She said it did not necessarily indicate purposive planning. It might be reflexive health maintenance, a species-wide behavioral trait that activated in conditions of inactivity regardless of strategic intent. I accepted that at the time. I want the Council to note that I accepted it, because what happened at Cycle 41 will be more meaningful in that context. What I want to add, for the record, is what the subject did with the remaining hours of each cycle after the exercise period concluded. Because this is where the session logs from cycles 30 through 41 begin to read, in retrospect, less like a containment record and more like a project log. After exercise, the subject would eat. Standard packet consumption, nothing unusual there. Then they would sit on the floor, not the sleeping surface, the floor, with the wrapper map in front of them, and they would study it. This was a dedicated period, not a casual glance. Our neural monitoring showed the same sustained problem state engagement Tarathis had flagged in the panel assessment sessions. The subject was working. They were working on the map, cross-referencing it against what they could directly observe about the habitat, updating it in small increments when they found a discrepancy between what the map showed and what fresh observation suggested. And then in the final period of each cycle before rest state, they would work, physically work, the sleeping surface disassembly, the casing scoring, the wire length fatigue tests, short sessions, carefully timed to conclude before our automated monitoring would flag elevated activity near the sleeping surface. I found this in the playback only after the incident. I had not caught it in real time because the monitoring team was accustomed to dismissing minor positional shifts near the sleeping surface as comfort adjustment. The subject had studied our monitoring response times. They had identified our team's tolerance thresholds for flagging low-level near-sleeping surface activity. They had calibrated their work sessions to stay below those thresholds. They were not simply resilient, they were methodical, and they had been studying us at least as carefully as we had been studying them. I accepted that at the time. I want the Council to note that I accepted it, because what happened at Cycle 41 will be more meaningful in that context. At Cycle 41, the subject attempted to remove the ventilation grill. They used the following materials: 4 lengths of wire drawn from the interior support structure of their sleeping surface, which they had disassembled over the preceding 10 cycles by working a loose joint at one end back and forth until the metal fatigued and separated. This process, our playback review showed, had taken approximately 4 hours of cumulative effort spread across those 10 cycles. The subject had worked at the joint for short periods, then stopped, then returned, in a pattern that closely resembled the kind of regular, patient effort a materials engineer might apply to a fatigue test. The wire, once freed, was approximately 40 centimeters long and of useful gauge. They had also fashioned a lever from the hardest section of a spent food packet casing, which they had been systematically scoring and hardening by scraping it against the wall seam at a specific angle, a process that took approximately 7 cycles, and which our monitoring team had logged incorrectly as a nervous tick. And a striking implement assembled from the remainder of the sleeping surface wire, wound into a dense coil, and packed into a cylinder of layered packet film, with an end cap formed from the thicker base plate material of the food packet. 3 separate tools, built from waste material, built over weeks in parallel, each one a component in a plan that required all 3 to function together. The grill was rated to 400 kilograms of direct compressive force. The tool assembly they had built was not capable of 400 kilograms, Our structural engineers estimated maximum applied force from the assembly at perhaps 160. They worked at it for 6 hours. The grill held. But, and I need the council to hear this clearly, the grill held with 3 of its 4 attachment points compromised. The subject had, using tools fabricated from what I had considered to be non-functional waste material, taken the attachment integrity of a security-rated grill from 100% to 25% in a single 6-hour session. They stopped when they recognized the remaining attachment point was beyond what their tool could address. They did not force it. They assessed the limit of the current approach, committed that assessment to the wall record they were keeping, and stopped, deliberately, conserving energy. Our maintenance team reinforced the grill during the subject's rest cycle. We reinforced all 4 grills, bringing each one to twice its original rated capacity. We reviewed the sleeping surface for any further removable components and replaced it with a solid molded unit that offered no disassembly points. We reviewed the food packet materials and replaced the outer casing with a softer compound that would not hold a scored edge, and reduced the tensile strength of the insulating film to below the level needed to form a workable sheet large enough to be useful. I filed an incident report. I wrote, subject demonstrated unexpected mechanical improvisation. Environmental adjustments made. Study continues. I noted my projection that the loss of raw material access would produce a rapid decline in directed effort behavior. I want to ask the council a question before I continue, and I ask it genuinely. At what point does a containment researcher recognize that they are no longer studying a subject, but rather watching a subject study the containment? I did not recognize it at cycle 41. I should have. What I had logged as an incident was, in retrospect, a proof of concept. The subject had confirmed to their own satisfaction that the grill attachment system was mechanical and fatigable. The fact that our team had reinforced it did not eliminate that confirmation. It merely changed the parameters of the next attempt. After the grill reinforcement and the material replacements, there was a period I initially interpreted as the approach of terminal plateau. The subject was quieter, less active. They spent more time lying on the new solid sleeping unit, looking at the ceiling. Their neural scans showed a shift in activity profile, lower sustained engagement, more cyclical patterns. Our biometrics specialist flagged it as possible onset of depressive state, which is a known precursor to terminal plateau in several species. The cortisol analog levels were moderately elevated, consistent with chronic low-grade stress, but the directed effort markers were significantly reduced from their prior levels. I was relieved, I confess. The study had run longer than projected and consumed more observation hours than budgeted. Our monitoring team had also been working extended shifts following the cycle 41 incident, and staff fatigue was beginning to affect review quality. I wrote in my session log that I expected plateau onset within the next 15 cycles. Then on cycle 53, the subject started talking. Not to anyone. There was no one to talk to. They began talking to themselves, extended, clearly structured monologues, delivered at a moderate volume into the quiet of the habitat, not the anxious muttering of a distressed subject, which we had seen from other species in prior studies, and which has a characteristic incoherence and repetitiveness to it. These were organized. They had the rhythm of someone working through an argument, presenting it to an imagined interlocutor, anticipating counterpoints. I had our xenolinguistics team analyze the recordings. They spent 3 cycles on the initial transcription. What they found was this: the subject was narrating their own situation, not in a distressed or disorganized way, in a specific, almost methodical way. They were reviewing what had happened, what they knew, what they had tried, and what they had not yet tried. They were cataloging their own attempts with an accuracy that suggested they remembered every detail of every cycle in the study, without notes, from memory. They were also, the xenolinguistics team noted, talking to an implied future self, using grammatical constructions that indexed a listener who was not present, as if the record of the words might somehow reach someone who would find them useful. There was a quality to it that the team's lead linguist described, and I am quoting her notes directly. She wrote that the subject spoke as if they believed the effort of speaking was not wasted even in the absence of a listener, as if the act of putting the situation into language was itself useful, regardless of whether the language was received. I have reviewed those recordings many times since the study concluded. I am not a linguist. But the quality of the subject's voice in those monologues, the tone, the pace, the deliberate care of it, the notable absence of what I would call despair, was something I have not encountered in any prior study, in any prior species. The subject did not sound like someone who believed they had lost. They sounded like someone reviewing the evidence before deciding what to try next. On cycle 61, they tried something new. The lighting array, the single illumination unit in the ceiling, operates on a fixed program. 16 hours of full-state illumination, 10 hours of reduced illumination rest state. The transition between states is controlled by a timed relay embedded in the ceiling panel behind a sealed access point. There is no switch. There is no dial. There is no way for a subject in the enclosure to alter the lighting state because there is no interface. We designed it that way deliberately. The lighting cycle is one of the few environmental constants the subject can observe but cannot affect, and observable but unaffectable elements are important components of the extinction protocol. They teach the subject over time that the environment is not responsive to their actions. This is a critical lesson. It is, in many ways, the central lesson of the closed habitat study. Your actions do not change your circumstances. Eventually, the brain learns this. Eventually, it stops trying to change circumstances. The subject on cycle 61 altered the lighting. Not the actual program. They did not access the relay. What they did was construct a physical shade from their blanket material and the small quantity of wire remnants they still possessed. I had failed to account for the small quantity not recovered in the post-incident sweep at cycle 41, a failure of process I have since corrected in the revision 15 protocol draft, and suspend this shade from 2 points on the upper wall using adhesive drawn from the nutritional packet residue they had been carefully storing since cycle 37. I want to note that, since cycle 37, for 16 cycles before they used it, they had been collecting the adhesive, not because they had an immediate use for it, because they believed, apparently, that it would eventually be useful. They were building a reserve. The shade itself was modest, roughly 70 centimeters square, enough to create a shaded area of the floor approximately 1 meter in diameter. It did not cover the full habitat. It did not eliminate the illumination, but it created, within the absolute environmental control we had imposed, a small pocket of self-determined conditions, a corner of the room that was, marginally, different from the rest by the subject's own action. Let me be clear about what they had done. They had not escaped. They had not breached the habitat. They had not found a flaw in the structure we had overlooked. What they had done was modify the habitat. In a habitat designed to be unmodifiable, they had modified it. This is a small thing in material terms. In terms of what it represents about the subject's cognitive state, it is not a small thing at all. Every species we have studied past cycle 40 has accepted the habitat as a fixed condition. They stopped testing it. They stopped trying to alter it. The habitat for them has become simply the world, the permanent context of their existence, not a problem to be solved. This acceptance is a prerequisite for terminal plateau. You cannot stop trying to solve a problem until you have accepted it is not a problem, but a fact. The subject at cycle 61 had not accepted the habitat as a fact. They were still treating it as a problem, and they were still finding within it small things to change. I called an emergency session with my research team that same cycle. There were 4 of us, myself, Tar Rothais from biometrics, Reth Venaz from xenobiology, and our study coordinator Pelirova, who had been with the project from its inception. I laid out the session log from cycle 1 through 61, and I asked them the same question I am now asking this council. When does behavior stop being displacement activity and become something we need to name differently? Reth Venaz spoke first. She said the human was doing what humans do. She said it quietly and without elaboration, and when I pressed her, she said that what she meant was this: human cognition, across every documented field study and every archived interaction in our xenobiological record, did not appear to have a passive state in the way we had defined that term for other species. Other species had rest states, maintenance states, terminal plateau states, hibernation states. Humans had rest, but the rest was not passive, even in sleep. The human brain produced complex activity patterns that our monitoring suite consistently flagged as problem-solving adjacent. She said she had noticed this in our subjects' rest state scans early in the study and had not flagged it because she had assumed it was within normal variation. I asked her why she had not flagged it. She said she had not flagged it because she had not wanted to prematurely alarm the team, and also, she said, because she had not been certain what it meant. She was still not certain. But she said she was aware that in the entirety of the xenobiological archive available to our division, she was not aware of any documented case in any formal study context or extended observation context in which a human had, under any condition, simply stopped. I asked her to be more precise. I asked, stopped what? She said, stop trying. There was a silence in the room after that, not a short silence. Tar Rothais broke it first. He pulled up his biometric read from the rest state scans on his data surface and turned it to face the rest of us. The neural activity traces from the subject's sleep periods looked, he said, like what he would expect from a waking organism engaged in low-intensity planning work, not the flat, cyclically irregular patterns of genuine rest, something more ordered. He had categorized them as anomalous artifacts at the time, a monitoring calibration issue, possibly, or a species-specific sleep architecture that didn't map cleanly onto our measurement framework. He said he now thought that was wrong. He thought the subject might not have a genuinely passive sleep mode in the way the protocol assumed. He thought the subject might be processing, evaluating, and planning during periods we had coded as rest. Pelirova asked what the practical implication of that was. Tar Rothais said the practical implication was that we had been counting our observation windows incorrectly. We had been recording directed effort events during active periods and coding rest state periods as null. If the subject was running directed cognitive effort during rest periods as well, then our directed effort event count was a significant underestimate of their actual activity level. We had been seeing less than half the picture. The room was quiet again after that. I remember looking at the session log on my data surface, 61 cycles of data, and feeling, for the first time in my career, that I did not know what I was looking at. Not because the data was unclear, because what it clearly showed was something I did not have a professional category for. Pelirova asked what we should do. I said we should continue the study. I say that now knowing it was the wrong answer, but I want the council to understand why I gave it, because I think the reason matters. I gave it because I believe the threshold existed. Every cognizant species has a threshold. The data I had in front of me, 61 cycles of a subject who had not plateaued, was unusual, possibly unprecedented in our database, but not impossible. Some species were simply more resilient than others. The human would plateau. It would take longer than any species I had previously studied, but it would happen. This was what I believed. I believed it because my entire professional framework depended on it being true. By cycle 80, I had stopped believing it. The subject, following the shade construction, entered a period of what I can only describe as increased creative output. Not because that phrase is precise, but because no precise phrase in my professional vocabulary covers what the session logs from cycles 62 through 87 record. The subject built a chair from the solid sleeping unit, which they discovered they could tilt at an angle against the wall and prop into a seated configuration, using the wire remnant as a brace. They had not been using it as bedding anyway, having adopted a floor-lying position some cycles earlier, which I now understand was deliberate preparation for this repurposing, not a random shift in sleeping preference. They developed a system of marking the wall in small, regular increments to track cycles independently of the food port schedule, because they apparently did not trust our schedule to be perfectly accurate, which it was, but their distrust of it was itself significant. A subject that distrusts the environment's reported time is a subject that has not stopped trying to independently verify the environment's properties. That is not maintenance state. That is continued engagement. They produced an extended series of what the xenolinguistics team identified as mathematical progressions, scratched into the wall with their scoring fragment. The scoring fragment, I will note, that we had attempted to eliminate by replacing the food packet casing with softer material, and which the subject had instead fabricated from a corner of the new solid sleeping unit. Spending approximately 20 cycles patiently working the edge of the unit against the floor seam, until a small chip separated and could be sharpened. They had solved our material restriction in 20 cycles. They exercised, every cycle, without variation in their commitment to it, though with consistent variation in the exercises themselves, adding load, adding complexity, getting, in Reth Venaz's clinical assessment at cycle 75, measurably and significantly stronger than they had been at intake. In the most physically demanding test, she could construct from the biometric data, comparing the force output of the subject's movements at cycle 1 against cycle 75. She estimated a 14% improvement in effective strength output. In a room with no weights, no resistance equipment, and no physical challenges, they had made themselves stronger by manufacturing the challenge themselves. I want to dwell on this for a moment, because I think the Council may be inclined to read it as simple health maintenance, and I want to argue that it is not. In all our prior studies, subjects in closed habitat conditions show a gradual decline in physical capability over time. They move less. Their muscle condition degrades at the rate consistent with reduced activity. This is expected. This is, again, adaptive. The brain conserves energy, reduces costly physical output, reduces maintenance of costly physical capacity. The human was doing the reverse. They were increasing physical output in an environment that placed no physical demand on them. They were spending energy to build capacity they had no immediate use for. Reth Venaz, when I raised this with her at our cycle 75 check-in, said she thought the subject was preparing. I asked for what? She said she did not know. She said she thought the subject might not know either. She said she thought the subject might simply be the kind of organism that prepares, continuously, without requiring a specific anticipated use case to justify the preparation. That word prepares stayed with me. A species that prepares continuously. That saves adhesive for 16 cycles before needing it. That builds physical strength in a room with no physical demands. That keeps a written record of every attempt, not for current use, but for future reference. That talks through its situation aloud, not because anyone is listening, but because articulating a problem is itself a step toward solving it. A species oriented entirely toward the future, even when every present signal says there is no future to orient toward. On cycle 88, the subject did something that caused me to close the study and convene this review. I need the Council to understand the sequence of events precisely, because the details matter. At the food port delivery on cycle 88 standard schedule, the subject received their nutritional packet and instead of eating it, placed it unopened on the floor directly beneath the food port panel. Then they sat and waited. The food port panel is a one-way delivery mechanism. It opens from the exterior, drops the packet into the port cavity, and reseals before the interior panel opens to allow the subject access. This two-stage sealing mechanism exists to prevent any possibility of a subject interfering with the port from the interior. The interior panel is lightweight. It is not a structural component. It is a cover plate because the actual structural panel is the exterior one, and that is what protects the port cavity from interior access. The subject had worked this out. I reviewed the session log later and found the precise cycle on which they had begun studying the port, cycle 44, 3 cycles after the grill attempt. They had spent 44 cycles studying the port mechanism before attempting it. 44 cycles of observation, of timing the delivery, of listening to the mechanism engage and disengage, of testing, in ways so subtle our monitoring team had not flagged them, the acoustic properties of the interior panel to establish its composition and thickness. 44 cycles. On cycle 88, when the rest state lighting cycle began, and our monitoring suite indicated the subject was in a low-activity state on their floor, our automated maintenance relay ran its standard overnight check of the food port mechanism. The check is automated. It involves the exterior panel cycling once through its open and close sequence to verify mechanism integrity. The exterior panel opened for a check duration of 2.3 seconds. The interior panel, per design, remained sealed during the exterior cycle. The subject was not in a low-activity state. They had been simulating low activity for what our playback review later established was the preceding 4 cycles, lying still, regulating their breathing to the pattern our biometric suite used to classify as rest, maintaining this precisely long enough that our automated flagging system had deprioritized monitoring their status. They had studied our monitoring response patterns long enough to know what rest looked like to our sensors, and they had reproduced it. They had studied our monitoring. When the exterior panel opened on its check cycle, the subject was already at the port. In the 2.3 seconds that the exterior panel remained in the open position, the subject drove their arm through the interior panel, which they had previously partially scored and weakened during what we had logged as incidental wall contact behavior near the port area over the preceding 20 cycles, reached the port cavity, and attempted to access the exterior mechanism. They did not succeed. The exterior panel closed on schedule, and our duty monitor, alerted by the breach sensor the moment the interior panel was compromised, initiated emergency sealing of the full port assembly within 4 seconds of the subject's contact with the exterior mechanism. The subject withdrew their arm. They had a laceration on the forearm from the scored panel edge, which they bound with a strip of blanket material without apparent distress. They did not use the emergency signal cord. They did not seek assistance. They sat down, pressed the bound arm briefly to their chest until the pressure slowed the bleeding, and waited. Then, after a moment, they began to speak. The xenolinguistics feed captured it in full. They went through the attempt step by step, noting what had happened, noting the timing of the monitor's response, noting what the exterior mechanism's behavior during the 2.3-second window had revealed about the lock assembly's configuration. They were not distressed. They were not angry. The voice our xenolinguistics team transcribed had the same flat, considering quality they had noted since cycle 53. A researcher reviewing a result, adjusting the model, deciding what the next variable to test would be. The post-incident review my team conducted in the following cycle found 3 things I had not previously registered. The first was that the interior panel had not been weakened in a single work session. The scoring had been accumulated across what appeared to be at least 30 separate sessions, each adding a small increment to the groove depth, each kept short enough to fall below our flagging threshold for sustained near-port activity. The second was that the subject had timed the attempt not to the food delivery cycle, as I had initially assumed, but to the automated maintenance check. a cycle they had no direct way of knowing about, because we had never disclosed the existence of the automated check to any study subject. They had inferred it, from the sound of the mechanism cycling, from the faint vibration in the port housing that our sensors confirmed accompanied the check sequence. They had deduced that there was an automated cycling event distinct from the delivery event, had timed its interval over a number of cycles, and had built their plan around it. The third thing my team found was that the subject had made a dry run on cycle 85, a partial approach to the port that our monitoring had logged as comfort-motivated positional adjustment near the food node. In retrospect, it was a distance calibration. They were measuring reach. I was in the observation suite when it happened. I watched the breach in real time. I watched our duty monitor respond. I watched the subject withdraw their arm and sit down. I watched them begin to speak. I did not close the observation feed immediately. I sat for some time and I watched, and I found myself doing something I have not done in 40 years of containment research. I found myself not certain who was being studied. I closed the study before the next cycle. I submitted this review request at the opening of the following work cycle. I have not re-entered the observation suite since. I want to be precise about why. I closed it not because the subject had escaped. They had not. The port assembly held. The alloy walls held. The reinforced grills held. The habitat performed exactly as designed in every structural respect. I closed the study because I had realized, sitting there in the observation suite, that the study's fundamental premise had failed to make contact with reality somewhere in the preceding 88 cycles, and that continuing to run the study would not produce the result the premise assumed. It would only produce more data of the kind that had already disproven the premise. The premise was, this species will reach a threshold. The data said, we have not found the threshold. Those are different statements, and I had been treating them as the same statement for too long. I want to give the Council the key summary numbers before I make my final remarks, because I want this argument to rest on data rather than impressions. The Closed Behavioral Extinction Protocol, Revision 14, is calibrated against a behavioral database derived from 16 prior closed habitat studies. The database covers 9 species. All 16 studies were designed to document the time-to-terminal plateau for each species. The number of cycles elapsed from intake to the point at which directed, non-survival effort effectively ceased. Terminal plateau is defined as the point at which the rolling average of directed effort events, tool use, communication attempts, structural modification, exploration behavior falls below 5% of intake day levels and remains there for 10 or more consecutive cycles. The shortest time-to-terminal plateau in our database is 14 cycles, recorded for a social hive species whose members showed severe cognitive degradation in isolation. The longest is 109 cycles, recorded for a highly individualistic territorial species that maintained aggressive enclosure testing behavior for an extended period before exhausting its strategy set. Both of those represent extremes. The database median is 37 cycles. Human subject, habitat 7, 88 cycles, no terminal plateau reached. No approach to terminal plateau observed. Directed effort event rate at cycle 88 was running at 63% of intake day levels. I want to stop on that number. 63%. That is not the reduced, attenuating effort of a subject approaching plateau. That is not even the plateau-resistant effort of an unusually resilient species slowly grinding down toward eventual compliance. 63% of intake day levels at cycle 88 is higher than 37 of the 48 data points in our full database at equivalent elapsed time. At cycle 88, our subject was more active, in terms of directed effort events, than the majority of species we have studied at their own day 1. And the quality of the effort had changed. Early cycle effort is generalized. The subject doesn't know what might work, so they try many things. Late cycle effort in every prior study is attenuated, fewer attempts, less variety, lower intensity. Our subject's late cycle effort was specific, targeted. It had been refined by 88 cycles of data collection that the subject had conducted on our habitat, on our monitoring patterns, on our maintenance responses, and on the properties of every material we had provided. The subject at cycle 88 was not working as hard as the subject at cycle 1. They were working more intelligently than the subject at cycle 1. They had learned more about the habitat than we had anticipated they would ever bother to learn, and they were applying what they had learned. Tarathis, reviewing the final biometric run for this report, noted something I want to read into the record directly from his written assessment. He wrote, "The cortisol analog readings I would expect from a subject at this stage in a closed habitat study, the readings that correspond to the grinding attrition of the organisms will to engage, were absent throughout the study's duration. Not low, not reduced, absent. The chemical signature that precedes terminal plateau in every species in our database does not appear, at any point, in this subject's biometric record. The subject did not produce the chemistry of giving up." He concluded his note with a question. He wrote, "Does this species have a surrender state?" I did not have an answer for him. I still do not. What the archive has given me, in the period since I closed Habitat 7, is this: no documented case, in any formal study or extended observation record available to our division, of a human reaching what we would clinically classify as terminal plateau. No documented case of a human simply stopping. There are cases of humans dying, cases of humans being physically incapacitated, cases of humans in extreme depletion ceasing movement because the body could no longer execute what the brain was still directing. But the body failing before the directed effort does, that is not surrender. That is not terminal plateau. That is the organism's physical envelope failing while the cognitive drive remains intact. The drive does not precede the failure. The drive outlasts the physical capacity to act on it. That is the distinction I am placing before this council. We have studied 9 species. In every case, the cognizant will to continue directing effort toward a problem expired before the organism's physical capacity was exhausted. The brain stopped before the body did. That is correct neurological behavior. That is what a brain is supposed to do. Conserve the organism by stopping the expenditure of costly directed effort when that effort is producing no return. Humans appear to do it the other way around. The council will want to know what recommendation I am making. I will come to it, but first I want to say something that is not strictly in my remit as a containment researcher, and I ask the council's indulgence. When I was sitting in the observation suite on the last night of the study, watching the subject speak through the record of the port attempt in that quiet, methodical voice, I found myself unable to maintain the professional distance that 40 years of this work had built. I found myself trying to understand the subject's interior experience, not as a researcher quantifying a data point. I was trying to understand what it felt like, from the inside, to be in that room, in that body, having attempted and failed to breach that habitat for 88 consecutive cycles, and to respond to the most recent failure not with despair, but with a calm inventory of what the failure had taught you. What kind of organism does that? What is it inside that keeps the directed effort funded, that keeps the brain allocating costly resources to a problem that has, by any rational accounting, demonstrated its insolubility? I do not have a neurological answer. I have observations. The subject saved adhesive for 16 cycles before using it. They spoke aloud into an empty room for 25 cycles, to no one, and the speech was not deteriorating. They built their body stronger for a physical demand they could not have known would arrive. They wrote a record of their attempts not for the cycle they were in, but for the next attempt, as if the next attempt was guaranteed to come. They simulated rest for 4 cycles to deceive our monitoring, which means they had been patient enough to identify the deceit as a viable strategy and invest the cycles required to execute it. None of those behaviors exist in my prior data set. None of them appear in the literature I have reviewed since closing the study. They are not extensions of known behaviors at unusual intensity. They are, as best I can determine, something different in kind. I want to try to articulate what I mean by that, because the distinction matters. When a resilient species in our prior studies remains active longer than the database median, they remain active in the same way, more of the same behaviors, extended over a longer time before the inevitable decline. They are more resilient. They are still doing what every other species does. They are just doing it for longer. The graph of their directed effort rate over time has the same downward arc as every other species, just shifted to the right. Our subject's graph does not have a downward arc. It has a decline significant in the first 20 cycles as the initial agitation state resolved, and then it levels. And then, from approximately cycle 40 onward, it begins to do something I had never seen in a closed habitat study. It fluctuates, but it does not trend downward. The rolling 30-cycle average, calculated at cycle 88, shows no statistically significant downward trend from its cycle 40 baseline. The subject's directed effort rate at the point I closed the study was holding, not declining, holding. I have shown this graph to 3 colleagues outside my immediate team since closing the study, without providing context. I asked each of them what they thought they were looking at. All 3 identified it as early study data, the graph of a subject who had not yet reached the inflection point of decline. None of them identified it as cycle 40-88 data from a subject who had been in the habitat for almost 3 months, because a directed effort graph that looks like that at cycle 88 should not exist. That is not a resilient subject. That is a subject whose extinction curve has a different shape than the curve every other subject in our database has produced. I do not know if the curve declines. I do not know what it does after cycle 88 because I closed the study. I closed it because I believed, and I still believe, that continuing it would not produce the answer the protocol was designed to find. It would produce more data of a kind we do not yet have a framework to interpret. What I needed first was for this council to know what we had found. What we have found is an organism genuinely and fundamentally oriented toward continuation, rather than cessation. An organism for which the concept of the problem being unsolvable does not, at some deep level, appear to register as a reason to stop attempting to solve it. An organism that, in the absence of any external signal that progress is possible, generates that signal internally and acts on it. I have filed the final Habitat 7 report under a new classification, one I have created for this purpose, because the existing system does not have a category that fits. The existing categories are successful extinction documentation, partial extinction documentation, inconclusive outcome, and subject failure. None of those describes what happened in Habitat 7. The category I have created is extinction threshold not located. The summary line I wrote for it reads, in 88 cycles of closed habitat observation under full revision 14 extinction protocol, no behavioral extinction threshold was identified for the study species. Directed effort event rate declined from intake day levels but did not reach terminal plateau. Study was closed prior to the subject's physical limits being approached. Whether a terminal plateau exists for this species, and at what threshold, remains undetermined. The study as designed is insufficient to answer the question. There is a secondary note, which I added in the researcher commentary field the morning I submitted this review request. It reads, the study as designed assumes the existence of a threshold. The primary finding of Habitat 7 is that this assumption may require revision. My recommendation to this council is not a redesigned study. I have thought carefully about whether to recommend one, and I have concluded that any study designed to find the human extinction threshold assumes, in its design, that the threshold exists. If it does not exist, or if it exists at a point beyond what any ethical study protocol could reach, the study would produce what Habitat 7 produced, a record of our assumptions failing to make contact with the subject's reality. My recommendation is a working group. A comprehensive review of every archived contact record, field study, military engagement report, and interspecies interaction document our division holds regarding the human species, specifically for any evidence bearing on the question of behavioral extinction. I am not the right person to lead that review. This question is larger than containment science. It belongs to the full breadth of our analytical apparatus, and it deserves that breadth of attention. Before I close, I want to add one final item from the physical evidence. When we cleared Habitat 7 after the study concluded, the maintenance team found, on the northeast wall, behind the position the subject had occupied for sleeping in the final cycles, a set of markings they had not previously logged. They had been partially obscured by the subject's position. They appeared to have been made over an extended period. The scoring depth varied, indicating many separate sessions. The xenolinguistics team spent 4 days with recordings of those markings. They were not a map. They were not structural analysis. They were not the mathematical progressions we had seen elsewhere on the walls. They were a record, complete, detailed, and written in the same flat, undramatic voice the session recordings had captured in the monologues, the voice of someone documenting facts rather than narrating an experience. The record covered every modification the subject had made to the habitat, every attempt at egress, every outcome, every adjustment made to the next approach as a result. The final entry was written shortly before the port mechanism attempt on cycle 88. The xenolinguistics team translated it as follows. Timing on exterior mechanism relay is automated and consistent. Response to interior breach is manual but rapid, approximately 4 seconds lag. Insufficient reach and time in current approach. Consider alternate approaches to extending reach or delaying the manual response. Query: is the manual responder always the same individual? If so, response pattern may be learnable over time. Not a farewell, not a surrender statement, not a conclusion in any sense I have seen a subject produce at the end of a study. A note written to a future version of themselves in a room they did not expect to remain in forever about what to try next time. I have read that entry more times than I can accurately count. I have tried to find in it some trace of what 88 cycles in that room should have produced in any organism I had previously studied. I have not found it. What I have found is a clarity that I find more unsettling than the breach attempts, more unsettling than the fabricated tools, more unsettling than the simulated rest states. What I have found is a species that does not appear to write endings. Only next steps. I close my report. I ask this council to open the working group and to read the full archive before that group convenes. Not the summary I have presented today, but every cycle, every session log, every biometric run, every transcript of the subject speaking into an empty room at the 37th hour of a 42-hour cycle, still taking inventory. Whatever we understood about the human species before this study began, the extinction data offers us one finding that I believe should inform every subsequent interaction, every contact protocol, and every strategic assessment this council undertakes regarding them. They do not stop. They have never stopped. And the question this council must eventually answer, before the repatriation queue releases our subject back into open space, is not what they are capable of when studied. We now know, in some measure, what that is. The question is what they will do when they are finally done being patient.